Hello community. Here, a small feature of Rust, right? We all know essentially these closures, right? So an closure is nothing more than, for example, doing a let closure is, and then you define some kind of value, and then, for example, you do x plus 1. But then essentially like egg, let's say mutable x, right, has been defined here as a 0. And then when we execute C once, right, we assert that x actually has increased, right, to 1. So if we would build this, then we will get a left and a right. We of course need to assign, right? So we have now like this. Now we get a problem because it needs to be mutable. And now, for example, we have some kind of correct output, right? So let's just debug x, just to make sure we expect it to be 1. Then the cool thing is if we call it multiple times, so here we call it like 5 times, we would expect now to be 5. And this is the case. But a lot of stuff is happening here, right? And if you read essentially like the manual, right, it says like we can have like 3 options, right? We have like 3 traits. One is the function trait, the other is the function mute, then we have the function once, right? And all of them are essentially unique in the way essentially how they operate, right? So function essentially says, okay, it does not take any environment, or it takes only read-only environment. So like a function which we defined before, like this, which has like not immutable and would just return x plus 1, would be perfect. And note that if we turn this around, right, we would use and we would use it. Well, 1 second. Okay, because I just want to have my Rust analyzer running. So if you see, well, let's avoid this. Now you will see we get an error, right? Because it says like a mutable borrow occurred here, right? And here essentially like we are immutably borrowing, and we are actually using it here. If we do it the other way around, then this will probably work exactly. So here we have the read-only borrow, and here we have the mutable borrow. So this will resolve into a function. This will result into a function mutable. And if we consume x, so for example, we would make like a function like let's consumed is, and we would like drop x inside the scope, then this would create like a function once. So what we learn from this, let's get this out. It's also called the C, right? C as well. Exactly. So we have to make a struct out of this, otherwise the drop doesn't work, right? So we cannot consume it. So maybe it's better essentially to do it like this, right? So we'll just make like a struct, which we call test, and let's implement some methods on this. And the impl will have like a function borrow, for example, which has a borrow value like self, which does nothing. We have borrow mute, which takes a mute, and we have something that consumes. And so in Rust everything is explicit. So essentially here we define that self is borrowed, right? Here we define that self is borrowed mutably and self. So now we can have now we can drive different kinds of functions, which explains it a little bit better, how the things work. So we got here now, for example, we make a test, is just a new test, right? And then we say, okay, let's make a function which borrows the value. Then we have function mute, which borrow mutes the value. And then we have a consume, which actually consumes. So essentially now we have three different kinds of functions, right? So the type system, or let's say we don't get real clear about this, but here we define the function. Here we define the function mutably, and here we define the function which consumes itself, right? Which can only be called once, and we can test this, of course, right? So for example, now we can run some tests. So for example, we can say function consume and just call it. Then we should be able to call it once, and if we call it twice, then we should expect an error, right? Exactly, because now it says, so we do the build. It says like, okay, consume moved, so the whole function moved, and we can't use that value again. Now, how does Rust do this? The compiler actually looks at what's being closed over, right? And then decides essentially what kind of structure to generate, because there's these sugars into a structure. And then essentially there is a call method on this, right? Which will call then this closure. And in all three cases, right, it will decide what to do. There's also an interesting thing, because essentially this, for example, takes a borrow mute, which also requires this function mute to be mutable. And so if, for example, if we would try to call this, and we would say, okay, let's call function mute, then it will have like a problem, right? And because now it says, okay, first of all, this should be undefined, because this moves in, and it has to be a mute, and then it will compile just fine. And the same with the borrow, right? So to summarize, so essentially like these function mute, so Rust has three kind of closure structures in these sugars too. But these are essentially like for example the function, right? These are traits. So it destructs to essentially a struct, then it implements this trait, right? The same as with function one, function mutable, which is also a trait which has a different kind of function, like call mute. And we got this function once, which has the function call once, right? So it desugars essentially to struct, which implements this. And when we call this function, right, or this closure, then it will just work like this. So how do you use these in your, let's say, function calls? So you can imagine making a function which is function. Then you say, okay, I want to take a function which has no return, right? No return value and no arguments, right? So to make it simple, right? So now you can make a implementation of this. So with that, this, yes, fix this a little bit. So now you can make an implementation of this by actually saying, okay, function call will be f, and let's do nothing with it. The same essentially for mutable, this, and the same for function once. So now you got three functions which can take different kind of things. Now you remember this one, right? It's also tune. So now, how does pattern matching, let's say, or how does this trait system work? Right? So if we say is function, yeah, and then we say okay, is function, right? Then it just compiles. If we would say is function mute, then it will fail, right? And why? And this is more clear. Disclosure implements function mute, not FN, right? Because it was tagged with the type system, but compiled as a function mute. And I try to put it here. Now the interesting thing is that what we can do, right, is if we say this is fine, right? This works. And this also works, right? And the reason this also works is because they say like this function once is the most usable function call, right? Because if something is function once, it can also be a function mutable, right? And we can call it multiple times, right? So essentially, like if you want to have the widest applicability of your function, then you would use this function once. So that's interesting, right? Now, if we consume, now if we run this function consume, then it will say yes, this is fine, right? This is good. But then again, if you go to mute, then it says no, right? Because again, it says, you know, this function implements function once, not function mute. So to summarize, in application, right? This is like function one is the widest applicability because this function once can take all functions, right? It can take function normal thing, like the only borrowing version of the closure. It can take the mutably version, right? And it can take the actual consumed version, right? Then function mute does not take this one, error, right? It does take the mutable version. And it takes the normal version. If we, of course, enable it. And then this one is the least applicable, which only takes this one, right? And it will error on the other twos. Like mute. Will it error on? And of course, it will error on the function, the fn consume. Yeah. So I hope this was a nice little tapas. It shows you the beauty again of Rust. And I wish you a very nice day. If you want to have any other tapas or any other things, please leave a comment and of course like and subscribe. Thank you very much.